All right, number 9. We're going to use permutations, combinations, fundamental counting principle, other methods as appropriate. So it wants to know how many different 5-card poker hands would only contain cards of a single unit. So that means if we did 5 cards, we want to know if it would only be clubs, or if it would only be spades, or if it only be hearts, or only diamonds. So there are 4 suits that we have to do this for. So there's 13 cards in each suit. And we're going to choose 5. So I'm just going to do this one time. 13, choose 5. Because we want to do a 5-card hand. I'm using 13 because I'm considering that I'm only with clubs, or it could be any one of these. So 13, choose 5. How many ways can I get 5 cards and they be all clubs, for example? This will be 13 factorial. 13 minus 5 is 8 factorial, and then 5 factorial. And then when we spell this out, 13, 12, 11, 10, 9, 8, and we'll stop at 8 factorial. 8 factorial will divide out, and then we have 5, 4, 3, 2, 1. All right, 5 and 2. 2 times 1 is 10. 5. And all of this will divide out 10 completely. And then 4 times 3 is 12, which will get rid of the 12 completely. So you're just left with 13 times 11 times 9. So this is how many ways you can get a 5-card hand of only clubs. Since there are 4 suits, 1, 2, 3, 4, and we can do this for any suit, we have to take this number and multiply it by 4, because we have to consider this 4 times. And that should give us all the possible ways of getting 5 cards of any single unit. So 13, 11 times 9 times 4. So 5,148 ways of getting a flush. $5,148. Make sure that's what we have. Yes. And then number 10, we want to verify that 12 choose 7 is equal to 12 choose 5. Okay, so yes, this combinations has a symmetric property of symmetry. And we're going to display that here. 12 choose 7 is equal to 12 choose 5. So we're going to do 12 factorial, that's the first number. And then you're going to have 12 minus 7. I'm going to go ahead and write it out this time. 12 minus 7 factorial. Then you have a 7 factorial. And then over here, we're going to have 12 factorial divided by, this will be 12 minus 5. And then another 5 factorial. So right now it looks different, but once you simplify, 12 minus 7, that's 5. So this side is going to be equal to 12 factorial on the bottom. 12 minus 7 is 5 factorial, and then 7 factorial. And then over here, when you simplify, your 12 factorial on top, you have 12 minus 5. That gives you 7 factorial and 5. So notice, both the bottoms are the same. So the property of symmetry says, if you when you count down, I guess I need to look at it like this. Let me just say if I use some numbers, 1, 2, 3, 4, 5, 6. So 6 is being my total. So all the numbers that add up to be 6 will be counterparts. So like 5 and 1 will be opposite. So they will be equal, kind of like these. Because these two numbers add to be 12. 5 and 7 add to be 12. And then 2 and 4, like if you had 6, choose 2, 6, choose 4, both of those will be the same. Okay, and then 6, choose 3 will be the last one. And I could have that 0. So 0 with 6. 0 with 6, 1 with 5, 2 with 3, and then you have that 1 by itself in the middle. So that's kind of what this rule says, is symmetry. So since 5 and 7 add to be 12, and that's what our big number is, then those will be symmetric. So then we can just finish solving one side. 12 times 11, 10, 9, 8, and then stop at 7 factorial. 7 factorial. And then we have 5, 4, 3, 2, 1. All right, so we're going to reduce all that we can. So I'm going to do, again, 5, 2, and 1 to get rid of the 10, 4 and 3 to get rid of the 12. So that leaves me with 11 times 9 times 8. 11 times 9 times 8. That's what we get with 12 choose 7 and 12 choose 5. 11 times 9 times 8. 792. And then, since they're both equal, we'll also get 792.